Hello and thank you for tuning into another video by Curiosmos. In today's mini docuseries, we will look at a new way scientists could search the universe for super advanced alien technology. So, buckle up and grab some popcorn. LIGO could use gravitational waves, ripples in space-time, to detect giant super advanced spacecraft traveling across the universe. But hold on, what is LIGO? LIGO stands for Laser Interferometer Gravitational Wave Observatory. It is the world's largest gravitational wave observatory and a marvel of precision engineering. Comprising two enormous laser interferometers located 3,000 kilometers apart, LIGO exploits the physical properties of light and of space itself to detect and understand the origins of gravitational waves. We will go into the definition of gravitational waves later in the video. Humankind seems to be very interested in finding out whether we are alone in the vastness of the universe. We very well might be, but as Carl Sagan said, it just would be a massive waste of space. I do not think this is the case. I also believe that there are some pretty good chances that some of the UFOs we see flying around in the skies and space could be technology, not of this Earth. This is still a theory, at least officially. However, several agencies like NASA and the Pentagon, for example, are working hard to find out. Now, an entirely new search aspect has been proposed. Scientists want to answer whether there are super advanced aliens in space by detecting evidence of a super spaceship. A giant alien spaceship? If an alien civilization has developed to a certain degree where they can build a gigantic spaceship, we might be able to spot the traces that this spaceship leaves behind. And to do so, scientists say we can look at gravitational waves because a mega spaceship could probably affect gravitational waves. As per a recent article by scientists from applied physics, detectors such as LIGO could, in theory, identify perturbances in gravitational waves left behind by a giant alien spaceship moving through space. Applied Physics is an independent research group of scientists and engineers that advises companies and governments on science, as per their website. Using LIGO to hunt for aliens. The research paper, which has still to be peer-reviewed, is currently available for download at the preprint server archive. It is expected to be published in the monthly notices of the Royal Astronomical Society. In the paper, the scientists make an interesting case as to why LIGO could be the right tool. In the first paper on the subject, Searching for Intelligent Life in Gravitational Wave Signals Part 1, Applied Physics discusses the present and future capabilities of gravitational wave observatories to detect warp drive-like objects. In collaboration with scientists from Carnegie Mellon University, Applied Physics is also developing the first machine learning-based model that will be sensitive enough to detect these warp drive signals and distinguish them from background noise. Ripples in space-time and aliens. Our variability to look for techno-signatures or even alien messages in the universe is very limited to tens of thousands of stars. We simply have not developed technology that allows for a broader search. As they explain, the types of electromagnetic waves we use to communicate are weak and weaker as they move further into the cosmos. This means it is almost impossible to filter out the noise existing beyond a few hundred light-years. Enter gravitational waves. Gravitational waves, as it turns out, are not attenuated in the same way as electromagnetic signals would be. This means we can therefore detect them at much greater distances. In other words, if there are super intelligent alien civilizations traveling across the universe with a kind of technology that was capable of interacting with gravitational waves, we might have the tools to detect it. As explained by the University of Birmingham, gravitational waves are ripples in space-time. When objects move, the curvature of spacetime changes, and these changes move outwards, like ripples on a pond, as gravitational waves. Have something to add? Visit Curiosmos on Facebook. Join the discussion in our mobile Telegram group, and make sure to hit the like button and subscribe. All links are in the description. Thank you for watching. Until the next one, goodbye.